The Fermi Paradox has been a key talking point among space enthusiasts as well as alien hunters. Modern legend has it that in 1950, the physicist Enrico Fermi met with colleagues during lunch break at Los Alamos National Laboratory in the United States. They were discussing the big topics of the day, when Fermi is said to have suddenly exclaimed, "Where is everybody?" or words to that effect. His precise phrasing is still up for debate, but the general meaning isn't. Fermi was asking about extraterrestrial life, and wondering why, despite all of the predictions that aliens were probable, we still hadn't discovered any. Fast forward to today, and while science, astronomy, and space travel has come on leaps and bounds in many other ways, the Fermi Paradox still holds true. We still haven't discovered alien life, despite there being now more predictions than ever that it must exist somewhere. So in this video, we're pitching 4 possible answers to this most famous of problems. 4 solutions to the Fermi Paradox. The first actually contradicts most of what we just said. It's that space is just too darn big, and that life is potentially too darn rare. Yes, we increasingly believe that life beyond Earth must be possible, but we've also increasingly come to appreciate that the universe is massive. When we talk about alien life, we often imagine that it's only just beyond our reach. That if we pointed our telescopes in just a slightly different direction, we'd find it. And it's therefore only a matter of time and of telescope tweaking before we can say with certainty, yes, aliens exist. But in reality, we humans wield nowhere near as much control or influence. We've been hard at space travel and research for around a century now, but it's only relatively recently that the first man-made objects left even our star system, the Voyager probes. And even then, neither Voyager has unshackled itself of the sun's gravitational pull, and neither will until they pass beyond the Oort cloud, a feat that, if it happens, won't happen for another 30,000 years or so. We have cast our net further via electromagnetic and radio signals, but even where these are concerned, we're only beaming out in earnest to an area around 100 light-years from Earth. That's in a galaxy that's more than 100,000 light-years across, and in a universe that stretches for 93 billion light-years at least. Clearly, we're not exactly a commanding presence in space at the moment, and it'll be a long time until we are, so it's easy to see how we could easily be missed. Now add into the equation various theories that life could be uncommon, most notably the rare Earth hypothesis, and what are the chances that aliens will ever be in communicable distance? The rare Earth hypothesis regularly comes under fire, but advocates suggest that it's not only the conditions for life that could be unusual, but also the emergence of life, even when those conditions are met. It therefore matters very little to rare Earth theorists how many stars and planets are estimated to be in the sky, because very few of those will amount to life, and even fewer will be anywhere near us. Paradox solved. Maybe. Our second option, the planetarium hypothesis, offers a totally different take on the problem. It says that aliens do exist and that they are reasonably close, but that we'll never know anything about them, and that's just the way they like it. This theory is partly built on the zoo hypothesis, a much-debated idea that Earth is like an enclosure in some kind of higher-level zoo, and that life on Earth is being watched as if caged by some kind of higher-level being. The planetarium hypothesis takes it a little further, though, and directly answers why we're apparently so unaware of our alien overlords. First put forward by science fiction writer Stephen Baxter in 2001, it loosely proposes that space, or whatever we understand to be space, is a lie. Instead, it's a virtual reality sim, purposely rendered so that whenever we look out into the universe, we see no signs of life, because that's how the higher powers want it to remain. In this instance, the sky is like a planetarium. It's a wholly artificial thing. Of all the solutions to the Fermi Paradox, this one is perhaps one of the least supported in the wider scientific community. But it does set up an interesting alternate take on the matter, where alien life is completely in control, and humans might never break free, let alone solve any paradoxes. Our third possible solution, the dark forest theory, also imagines that aliens do exist and that they could be close. But this time, they're not in total control. In the dark forest theory, alien civilizations don't reveal themselves to us or to anyone else for that matter because they're extremely wary. Alien life moves slowly through the universe, with the primary goal being not to attract the attention of anything else that could kill it off. And when it comes to taking over galaxies, they're just not that interested. Dark forest aliens are careful rather than cavalier, and guarded rather than gunslinging. It's an idea first put forward again by a sci-fi writer, this time Liu Cixin, in his Three-Body Problem book series. Here, the Fermi Paradox is answered because it leaves us with the feeling that aliens actually could be all around us. It's just that for as long as they perceive humankind as a potential threat, then they're never likely to approach. For some, we ourselves should be applying a similar policy to our own efforts towards space exploration. Missions like the Voyager probes and the beaming out of radio signals may be pioneering, but they've always been met by some with a degree of trepidation. The question usually asked is it safe to make ourselves known? Finally, though, what if none of the above really matters at all? What if alien life isn't uncommon as per the rare Earth hypothesis, it isn't all-powerful from a distance as with the planetarium hypothesis, and it isn't common but careful as per the dark forest theory? What if it's already here, right in front of our eyes? Conspiracy theories abound claiming that aliens are among us, whether it's a shape-shifting reptilian race sent here to destroy us, or a united front that's hijacked our governments to assume total control on the ground. We're not so interested in those ideas today, but it still stands that one potential solution to the Fermi Paradox is that aliens are actually all around us, it's just that we can't sense them. In early 2020, the British astronaut Helen Sharman made headlines for the seemingly sensational claim that aliens could be, quote, here right now and we simply can't see them, end quote. Speaking to the Guardian newspaper, Sharman also referred to the possibility that aliens could have a totally different biological makeup to us, where carbon and nitrogen aren't as essential to their existence. In writing about Sharman's comments, the astrobiologist Samantha Rolfe has gone further still, suggesting that if such life did exist, then a shadow biosphere could also exist to house it. And so, when Enrico Fermi asked back in 1950, "Where is everybody?" he may have actually, unknowingly, been in close proximity to aliens at the time. Or so the theory goes anyway. In truth, these aren't the only possible solutions to the Fermi Paradox. There are plenty more, and some more outlandish than others. But these ideas do broadly stretch across four possible big-picture scenarios. 1. There aren't any aliens, or at least none that are close by, and that's why we haven't found any. 2. There are certainly aliens, but they totally control us, and that's why we don't know about them. 3. There are certainly aliens, but they're totally scared of us, and that's why they're so quiet. And 4. There are aliens all over the place, it's just that they're invisible to us. What is your favorite theory? Or do you have a better answer to this great cosmic conundrum? For now, those are four possible solutions to the Fermi